Hello everyone, this is Melba and today we will be discussing gluconeogenesis. So basically it is the process of the formation of glucose. But the glucose is not formed from a carbohydrate carbon. It is made from non-carbohydrate precursors. And these non-carb precursors are either pyruvate, 3-phosphoglycerate, or glycerol. So gluconeogenesis occurs during the time when a person is fasting or hasn't eaten in a while and the body is out of glucose. So in this emergency, our body utilizes other non-carbon and carbohydrate precursors like pyruvate, 3-phosphoglycerate, or glycerol to make glucose. And glucose is essentially used to provide energy to the brain, nervous system, erythrocytes, renal medulla, and other embryonic tissues. But this is the main gist of it. So, gluconeogenesis is just like glycolysis, but it goes in reverse. And there are 7 similar steps, but 3 different. So, those 3 different steps I will be talking about today. And it begins with the end product of glycolysis as it goes in reverse. So the pyruvate must convert into phosphoenol pyruvate, and the pyruvate moves to mitochondria because there are certain enzymes present in mitochondria that are not present in the cytosol. Hence, to further go through this mechanism, the pyruvate molecule must move to mitochondria, and the reaction that occurs here is as follows. So the pyruvate uses pyruvate carboxylase enzyme along with one molecule of ATP to produce oxaloacetate and the byproduct of ADP. And the enzyme involved in this reaction is called pyruvate carboxylase, and the cofactor that helps with this reaction is biotin. Now keep that in mind, we use 1 ATP in this reaction. And then the oxaloacetate further converts into malate, and I'll be telling you the reason why. So here the enzyme used is malate dehydrogenase, and the oxaloacetate uses one molecule of NADH and produces malate. So why does this convert into malate? Because there are certain transporter enzymes present in the mitochondria that are not facilitative towards oxaloacetate. Hence, it needs to be converted into malate to be able to use those enzymes and to exit into the cytosol. So why the long way? Because there are certain issues since cytosol in the cytosol there isn't enough NADH molecules to facilitate the conversion of pyruvate to oxaloacetate. Hence, it needs to go into mitochondria and undergo certain reactions to produce more ATP. Um, and so it is converted into the desired product. Then after this reaction, the malate from mitochondria leaves and enters cytosol. So here that malate we talked about is converted into back into oxaloacetate. And one molecule of NAD is used, hence producing an NADH molecule. So keep that in mind that we used one molecule of NAD. So as we talked that in the glycolysis there are 3 steps that are different from the steps involved in gluconeogenesis. The first one was the conversion of pyruvate into phosphoenol pyruvate, and the second one is going to be fructose 1,6 bisphosphate into fructose 6 phosphate. So this step is fairly easy and it's pretty straightforward. I'll be writing the short forms because it takes a lot of time to write. So the fructose 1,6 bisphosphate is converted into fructose 6 phosphate using one molecule of H2O, hence producing phosphate. So we will also keep this in mind. And the enzyme involved in this reaction is fructose 1,6 bisphosphatase, and the cofactor is magnesiumine. And lastly, the third step that is different in gluconeogenesis and glycolysis is the conversion of glucose 6 phosphate into glucose. This is the this is the end product of gluconeogenesis, and this is also fairly easy as the glucose 6 phosphate uses water and an ATP to convert into glucose with the byproduct of a phosphate group. So here we will keep in mind then that one molecule of H2 and a molecule of ATP was used, and the enzyme involved in this reaction, an enzyme isn't involved, and the cofactor involved is the magnesiumine. So what did we gather from all these reactions? The sum of the whole entire equation of gluconeogenesis will turn out to be, as we saw, a molecule of ATP was used, a molecule of NAD was used, H2O was used, and pyruvate, another molecule of H2O, and an ATP was used. So we would multiply our reactants by 2 because the glucose molecule requires 2 pyruvate. This reaction we used 1 pyruvate, so in order to make 1 molecule of glucose we need 2 pyruvate. So we will multiply our reactants with 2 in the equation. So instead of writing 1 pyruvate, we would write 2 pyruvate. Instead of 2 ATP, we are going to write 4 ATP. Instead of 2 GTP, we are going to write, 1 GTP, we are going to write 2 GTP. Instead of 1 NADH, we would write, 2 NADH with 2 protons. And instead of 2 molecules of H2O, we would write 4 H2O. So these are the reactants, and the product would be 1 molecule of glucose with 4 ATP gives 4 ADP, 2 NADH would give 2 NAD positive, 2 GTP would give 2 GDP, and the phosphate group from here and here would accumulate into 6 phosphate molecules. So this is the reaction, the cycle, or whatever you would call it, of gluconeogenesis. If you have any more queries or you would like to give constructive criticism, that is welcomed. And make sure to like and subscribe, that would help a lot. Thank you.